This conference is brought to you by CallStack, your React and React Native development experts.
Hey everyone, my name is Rene and I'm a senior software engineer at Zalando. And as you heard, round about 1 year ago, we started looking into React Native, and I'm here to tell you about this journey and what we learned on the way. So actually, how many of you know Zalando? Maybe raise your hands. Also before the conference? Okay, nice. So for those that don't know, well, with 50,000 employees and about 50 million customers, we are working at this very interesting scale where it's not only about the scale in an infrastructure sense, but also on an engineering sense. How can you build an application that, well, hundreds of engineers can work at the same time on every single day, or sometimes even on a very single screen? So let me introduce you to the Zalando app before the React Native migration, or before we started looking into React Native. So we had more or less two very large code bases, one for iOS, one for Android. And they made up around 500,000 lines of code that were written within 10 years. And as you can imagine, in 10 years, there's a lot of things that will happen throughout one application. We went through language migrations, like from Objective-C to Swift, or completely overhauls of the architecture. And last year, we also thought, well, it's really time for the next step for the Zalando app. We wanted to go the next milestone. So before we went into this direction of building a new architecture, we thought, well, what is actually the requirements of this? What do we actually want to achieve? What's the point of this migration? So as you can imagine, often in development, when you especially want to scale things, you want to, well, improve the developer experience so that we can build experiences much faster than we are used to. At Zalando, we are doing lots of experimentation, so we want to have very quick iterations. And this is something that React Native promises, right? Then the other requirement that we had was, well, we really need to be able to integrate this new architecture into the existing app. Like you heard this term brownfield and greenfield before, but at such a scale with 500,000 lines of code, as I mentioned, you cannot just go ahead and say, well, let's just rewrite the entire app. Like, let's hold every other development for like 1 or 2 years and rebuild everything. That's usually not possible, or at least not feasible, and also a bit scary to do. And last but not least, you are not really often doing these types of migrations. If you're working on such a large-scale application, this is something that doesn't happen every now and then, but it's a very rare occasion. And we wanted to make sure that if we are doing this, we consider it from multiple angles and make this architecture ready for whatever is coming in the future. So we wanted to include web into all of this. Most of the time when you're talking about cross-platform, especially with React Native, we are talking about iOS and Android and maybe some other platforms, Windows, Vision OS nowadays. But we wanted to include web into all of this as well. So let's dive a bit into our first topic of today, which is the progressive adoption. How can we actually integrate React Native into an existing application? And I'm paraphrasing here myself, can't be that hard, right? That's what I thought, was a very naively thought back then. And especially if you start Googling it, you might end up at this React Native documentation and think, okay, it should be easy, right? Unfortunately, it's not that easy. There's lots of gotchas that you need to learn. So let's look at what we actually want to have. We want to integrate, right? We don't want to replace. We don't want to build a new app, but we want to replace maybe screen by screen, maybe parts of the screen, and then control it with A/B tests. And then what's also important is you want to do that in a non-invasive way, which means that you don't want to slow down the existing development of the existing app. You don't want that suddenly every single app engineer needs to get their system ready for things like Node, NPM, and all these kind of tools. As if you're coming from a web background, you're used to these things, but we don't want to make these changes to the running engineers and disrupt their behavior. And last but not least, we also want to make sure that we are separating our problems and our concerns, because very often when you are creating new architectures, especially in a progressive way, you end up with kind of inheriting technical debts from your previous architecture, because in some way you need to glue things together because you want to integrate. But that's not something we want to have, or we want to avoid as good as we can. So how can we do this, or how did we do this at Zalando? So let me walk you through this, graph here. On the very left side, we have something that we call the React Native entry point. In this sense, this is your typical React Native code. This is your React Native root component. Maybe some of you know from when you first time set up a React Native application, you register this component and mark it as this is your root component. This is what renders your entire app. But instead of making this as like an app package, we just put this into a node package and expose this, what we call the entry point component. Now, the interesting part and different part to most other adoptions is that we have two consumers now of this package. The first consumer is what we call the dev app, or sometimes we also like to mention it as a standalone app. This is a pure React Native app. It has no dependency to the existing app at all. Just a pure React Native application that supports all the React Native code. And this is actually very crucial, even though it's just for development, but this is our way to make getting started super easy for all kinds of engineers. Because we have two types of angles that we need to look at. There's the angle of web engineers that are coming now to this app world with suddenly having things like Xcode, Gradle, Android Studio, you name it, and all its quirks. And on the other hand, you also have the native engineers coming to this weird web ecosystem that is also quite different. And one thing that we did to make this migration much easier is that we took this React Native developer app and we uploaded it. We created a binary out of it. And what we then did is, and that's something important to remember, that if we are writing React Native applications, the code ends up as some JavaScript bundle. And the great news about this is that, well, React Native doesn't care where this JavaScript is coming from. So what you can do is you upload this pre-built binary of the developer app, and then you just let it connect to your local Metro bundler. This means no compilation, no quirks with Xcode or Android Studio, and you have a very quick way to get started. And then, of course, also, I said it doesn't care where this bundle is coming from. So whether it's coming from your local Metro bundler that is maybe running your network or even on the same machine, but it could also be something that on the CI pipelines have been created. Like with this dev app, what we created is that you can very quickly switch between the different environments. Like maybe you will want to quickly check how the main branch is working, or maybe you want to quickly check the branch from a colleague that created a pull request to test something. And that makes this very scalable and much more easier to get started. Now, the other consumer of this framework is, or of this entry point, is what we call the framework. And this is where the production app comes into play. So what we do is, on a high level, it sounds actually quite simple, is what we do is we package React Native, including its code, including all its dependency, the turbo modules, and so on, package it on iOS into something called an XC framework. And what we do is we push this framework to SPM. So now this dependency, this framework, can be installed just like any other native dependency on iOS. And then the same happens on Android. Just that we are not talking about an XC framework, but we are talking about something called an AAR, which is more or less the same, just a different type of package. And now, now we have this framework that is more or less a normal native dependency that any native app can consume. But what we want to avoid, because remember, we want to separate concerns, is we don't want to really expose React Native to the app. We don't really want to call the React Native APIs directly, but instead we expose a very small API, a very small public API in this framework, which consists mostly of two things. One thing is the initialization. This is very important to have separated, because imagine there's a difference between maybe you want to initialize React Native when the app is starting, or maybe you want to initialize it when the first screen that is built in React Native is actually started. So by separating this initialization, you can decide yourself. You can even run it in A/B tests. That's what we did, for example, and this makes it much more easier. And then the last point is, well, creating views. This is then what ultimately creates these on Android activity or fragments, or the views on iOS, which will be powered by React Native. But from the point of the React Native app, it doesn't really care that much where this is coming from. It's just providing some views, it's providing an initialization, and it doesn't necessarily care about the rest. And now the very cool thing about this is that if you also want to create such a framework, you don't need to go through or start from scratch. Thanks to CallStack, there is actually something called the React Native brownfield library, and you will pretty much find every scripts, the building scripts, the Gradle plugins, you will find there, and you can get very similar architecture like we have. And then there's also RUC, which you might have heard in the previous day. Okay, so we kind of solved the progressive adoption. We have a way to, in a controlled way, include this, what we call the framework, and then in our native app, we can control it whenever we want. We can show these screens when we want. We can control them through A/B tests. In the beginning, I said we also wanted to consider web. So how are we going with this? Well, first of all, we need to take one step back, because when we say we want to have cross-platform with web, then we need to first define what we actually want to have here. Because this is a bit of a dangerous area, or it's a double-edged sword, because you want to avoid this, this problem where you might think, okay, if I'm doing a cross-platform application written once for all platform, then you might fall into this trap where you build 100% of your code maybe in JavaScript, and you want to force everything to be shared. But the truth is, there are platform differences, and most often you also want to have these platform differences. I'm sure every one of you has preferences from whether they are using iOS or Android or even the browser, and usually that has a reason. Like, these platforms behave slightly different. They maybe have different gestures or very subtle scrolling differences. And just because we want to create a cross-platform application, we don't want to sacrifice these and create like a super generic application that looks exactly the same everywhere. But then, of course, still, that the whole point of doing this cross-platform with web is we want to be able to share most of the code that can be shared. And of course, this is a bit subjective, because what does most code mean? But in the end, you need to find like this fine line or this balance between sharing enough code so that this whole architecture makes sense in the first place, but also not, again, forcing you into this trap where you force yourself into this paradigm of sharing everything. And then another very important point is that often we just talk about code, right? We write code once and then cool, it works, it runs even everywhere, nice. But what's actually important as well is, what about the concepts? What about the architecture itself? What if we are not sharing a code, but, well, if we don't share the code, what if we could at least share the same concepts? Think of it like sharing the same API, which has completely different implementations internally. If you put yourself into a shoe of a cross-platform engineer, you don't want to learn like new concepts for every platform, but for things like data fetching, caching, and similar things, they don't need to be different. Maybe the implementations are different, and that's fine, but if you make sure that these concepts are the same, well, you make your engineers much more flexible. So now since we're talking about web, it's also important to really understand what we actually already have in web at Zalando, because here we have a very interesting starting point. So in web, we have something that we call rendering engine, and don't get too confused by the name. It's not really rendering, but just that's the name. Think of it more like a Next.js-ish framework, but more shaped for our own Zalando needs. The things that I mentioned earlier, like data fetching, caching these data, this is something that rendering engine handles for us. And in general, tries to abstract as many common applications needs as possible. And the way it looks like, to give you a little sneak peek, but don't worry, we have a nice blog post or multiple blog posts that you can check out. But what you do is we have this declarative API where you create something that we call modules. A module is, you can think of it as like a self-contained, completely independent, supercharged React component in the end. And in this declarative API, you start to define what you actually need for this component to work. In this case, we have some component that, well, first of all, needs some data from the GraphQL service that we have. So we just declare, hey, I need this data. And then second of all, we declare what we call here the with process dependencies, is while these modules are supposed to be self-contained and completely independent, of course, if you think of a website or even of an app, you will not be able to avoid dependencies. So with this with process dependency method, we define dependencies to other modules. And we kind of say, hey, I also want to render this other child module. I don't care where it's coming from. I don't import it. I don't care about the implementation, but I just pass the name of it. And then this rendering engine framework will take care of giving you exactly this. And in the end, we have a with render, which renders your React component. And now this is the interesting thing, that back then when the engineers at Zalando designed this, didn't really think about it. But if you look at this API, there's nothing platform specific here. This is just JavaScript. And the only thing that might be platform dependent is really this last part about rendering data. So what we said at that time 1 year ago is, why not use this internal framework that we already have and solves a lot of needs for the web? Let's take this and make this available for the Zalando app with React Native as well. So to make this puzzle piece complete, to complete this picture of making this framework that comes from the web available for the app as well, is there's two major pieces missing. So one is the UI itself. I said the React rendering engine only cares about these React components. So if we find a way to create React components that are cross-platform, well, then we can literally share that code, right? So we are using something called React Strict DOM. Who of you actually have heard about React Strict DOM? Okay, that's good. So React Strict DOM is actually a pretty nice API that on the surface does a very simple thing. Because if you look at the code, what you can do is, well, you render HTML elements. You render something like H1, div, input, label, you know these HTML elements. And now React Strict DOM will take care of translating these to the platform respective components. So a div, well, becomes a div in the web, but on React Native, it would become a view with maybe some additional styling applied. So React Strict DOM makes building cross-platform components quite easy and make it completely look like a web. So this is a bit different compared to React Native Web, where we kind of go the opposite direction, where we make React Native work in web. Here we make web work for React Native in that sense. And then to also complete this, React Strict DOM also adds some missing CSS capabilities, things like pseudo classes and a bunch of more things. But of course, most of the time you don't want to directly write HTML yourself, because how many times you're gonna create a button component? How many times are you gonna use the same type of typography or the same type of card and so on? So of course, what we did is we also created a component library, which, well, builds these UI components that can be reused everywhere. And now, an interesting thing that you can now also do, or that we also are doing, is as long as you're using these component libraries itself, actually the fact that we are using React Strict DOM doesn't even matter that much. For all it takes, it could also be this dialog component here, for example, or button component could be also written in something completely different. And there's actually a very underrated feature right built into Metro that everyone can use, which is this .native.tsx file pattern. And this makes sure that if you are importing a file, well, it first looks for the same file with this special extension if you're on a native platform. You can have a .web file, you can even have .ios, .android. And this way, also coming back to my original thought where I said, well, we want to have sometimes platform differences. With this, we can relatively easily do this. And with this, we can even kind of hide away React Strict DOM if we want to. If we want to create a truly native component in our component library, well, then we can do it. And we don't need to force ourselves too much into this. And now the last piece of this to make this framework ready for the app is, well, state management. State management is a tricky part. It contains usually a lot of business logic. It contains a lot of dependencies throughout different types of state. And the question, of course, is also, do you even want to share that part? What we did is we created this thing that we call traits, which for all it takes is really very, very similar to what you know maybe from Zustand or even Redux. It's a state management library. But what we did on top of that is we very strictly typed the actions and the state of this trait. So instead of just writing them directly, we write these types down for actions, which are things like adding a product to the cart, navigating to a screen. These are actions that will trigger something that might change the state or have maybe some side effects. And then the state, which contains things like, well, is the customer currently authenticated, or what products are in the wishlist, and so on. And if we have now these types, what we can also do is in our modules, again, we don't care about the implementation of these. What we can do is, well, we can say, I need the navigation trait, wherever that is implemented, I don't care, and call some action of it. But now it's up to us to really decide, do we want to share the logic of this? Do we want to literally share the same code? Do we want to just have two completely different implementations, or maybe even on iOS and Android, something else? It's up to us. And that's the important part, is that when you do the cross-platform, make always sure that you have these options. You have these options to go fully native, have the option to write something shared, but don't force yourself into something where you cannot really go back anymore. So to wrap things up, as a conclusion, we have 3 points here. One is about, yes, the gradual adoption is a bit tricky. So if you are planning to do it, luckily now it's a bit easier, but still, yeah, plan some extra time. It requires a bit of a non-standard method. And then, well, cross-platform is a double-edged sword. And yeah, just make sure that if you want to do cross-platform, make sure that you really define what you want to achieve with this. What do you want to share? What do you not want to share? And again, don't force yourself into this mindset of, okay, I need to share everything, or don't do it at all. And then last but not least, I don't think I need to talk about this too much in this audience, but in the end, React Native is a game changer. Of course, it has its challenging parts, but in the end, for us, it's has been super helpful. And we have a Zalando booth in case you haven't seen that yet, so make sure to check that out. We also have a lot of Zalando folks running around here, so say hello to us. And with that, thank you very much.